Hello everyone. Today I'm going to share you something regarding how to solve some question in physics A or S level. This is coming from book from CUV or from Hodder. From Hodder, and I put one of exercise, one of uh, example or worksheet in this book. You can see here. I choose about moments, moment of a force. Yes, you can see here some of question. We have actually four question in this section. I try to solve this. Hopefully it's maybe useful, for you to gain up the knowledge about the moment of a force. Okay, let me try for number one. You can see for number one first. I try to block first about number three and four here, so you only see on the number one. Okay, the number one is a uniform rod has a weight 14 Newton. It is pivot at one end and held in a horizontal position by a thread tied to its other ends. And so in figure 4.37, the thread makes an angle of 50 degree with the horizontal. Yes, calculate. We have two question, A and B. The first question, the moment of the weight of the rod about the pivot. Yes, and the second one is the tension T in the thread required to hold the rod horizontal. Yes, yeah. Now I will try to solve this question first. Number one. Yes, we draw first about rod. And then rod has tension drop. Yes, T, and has angle about 50 degree. So, and we have distance of the rod or length of the rod is 60 centimeter, and pivot is in here. Okay, we draw first about the force on the rod. For the first one is the rod has weight. Weight, W as F times G. And then the second one is the have tension drop. This is T cos 50, and here is T sine 50 degree. So question one is, the moment of the weight of the rod about the pivot. Yes, the moment of weight, W. Yes, they only force of the weight, times with, let's say this is distance, or this is mg d, or we have mass, or already we know about the weight is 14 and d is 0.3. Because this is in centimeter, we need change into meter. So a half of 60 is 30 in centimeter, and we uh, convert into meter 0.3. So we can calculate this. 14 times 3. Yes, 4.2. Yes, 4.2 Newton meter. Okay, we get the answer of A question. And B question is, The tension T in the thread required to hold the rod horizontally. Okay. Yes. Okay. I think we need to find T first, yeah. By yeah. Yeah. This is about mg times t, the 0.3 mean minus t sine 50 equals times 0.6 equal to 0. And then we can say here, yeah, t sine 50, yeah, this is 0.3 of mg, yeah. Yeah, actually this is we already here, yeah, 4.2. Yes, sorry, this is 14 first, yeah, divided by 0.6, or here is 4.2 divided by 0.6, yeah. And for the final t is 4.2, yeah, divided by 0.6 sine 50. Yes, you can find it. Sorry, oh, I'm sorry. You can find it by from a calculator. Yeah. No. The question is not until here. The question is, yeah, the tension T in the thread horizontal to hold the rod horizontally. Yes. If we know here they have a normal contact force, yeah. So the question is t cos 50, yeah, t cos 50. So mm, if they need t cos 50, so t, oh, t cos 50, yeah, this is equal to 4.2, 0.6 sine 50 time cos 50, or yeah, I think 4.2 divided 0.6 is 7, yeah. So this is 7, and sin over cos is tangent, so we can say this is tangent of 50. Yes, this is about the uh, what we find question on B1, yeah, as the t cos 50, how much is. Yes, I'm not bring any calculator, so you can use the calculator. How much 7 divided by tangent 50, yeah. Okay, then for number 1. No, number 2. Oops. Yes, find the number 2 one. Yes, a ruler is pivoted at its center of gravity, and weights are hung from the ruler as shown in the figure 4.38. Calculate A and B. A is the total anti-clockwise moment of about the pivot. Okay. And B question is the magnitude of the force. Okay. Yes, I think we don't need to draw this diagram, yeah, so we can use this diagram and we can calculate all everything we need to find is question A. On the anti-clockwise moment, yeah, total torque on the anti-clockwise. So if we see the sixth one is anti-clockwise, so we can say 6.0 times 40 centimeter is 0.4 in meter, yeah, and then 2.5 also, so we can say plus 2.5 times, yes, this is 20 centimeter, we can say here is 0.2 in meter, and this is 4 is clockwise, this is 2.0 newton also in clockwise, so we don't need to find the moment of force F and 2.0 newton. So here 6 times 0.34, yes, 2.4 plus 2.5, yeah, times 0.2 is 0.5, yeah. So we have number here as 2.9 newton meter. Yes, this is the answer of A question. Okay, how about B question? Oh yeah, don't forget to subscribe my YouTube channel. Yeah, like if you like this session, or give me the feedback, give me the comment of the blog below. Yeah. So B question is the magnitude of force F. Okay, F and 2.0, yeah, F and 2.0 is on the clockwise, so total moment equals to 0. It's mean all the moment in the clockwise it's equal on the moment anti-clockwise, so we can see here, yeah, 2.9 as the anti-clockwise moment equals to force times, this is 25 in centimeter, 0.25, yeah, and plus 2.0 times 4.5 in meter, 0. Meter, so 2.5, this is same thing with 0 to 5 of force plus this is 0.9, and we bring it, this is equals to 2.0, right? 2.9 minus 0.9 equals to 2.0, this is 2.5 force, so force, yes, this is divided with this one, yeah, this is equal to 8 newton. Yeah, finally we get the B answer, yeah. Okay, thank you very much for you watching this video until the a half of video, because we have a half more of this video for number 3 and 4, yeah. But I need you to subscribe my YouTube channel. Please give me a feedback by filling the comment on the below block, yeah, on the below window, yeah, sorry, on the below box, yeah. And don't forget to press the button notification uh, if you want to see other video on my YouTube channel. Yes, thank you very much, and go to the number 3. Oh yes, uh, let you see about the number 3 one. I will use other, yes, here. Okay, number 3 is, oh sorry, you don't see. Okay, yes, yeah, Number three is a uniform plank of weight 120 Newton rests on two stools as shown in figure 4.39. A weight of 80 Newton is placed on the plank midway between the stools. Calculate the force acting on the stool at B, the force acting on the stool at B. Yeah, A and B. Yeah, we need to find this. Actually, this is about normal contact on the pivot on B point and A point. Yeah. Okay, now we need to draw about this diagram. Yeah, hopefully you can see my handwrite. Yeah, yes, we have plank. Yeah, and then we have this is 4 meter, and we have pivot here. This is about 0.5 meter, and we have pivot here. This is around 1.0 meter. Yes, and with 80 placed on the plank midway. Yeah, I think here midway. Yeah, midway between pivot A and B. Yeah, as 80 Newton. We need to find the first one is normal contact on A. Let's say this is normal contact A and B. Yeah. Okay. No. The force acting on the stool at A, we can use this by pivoting on B point. Yeah. So total torque on B equal to 0. Yeah. If we need to find the A force, yeah. So use B, yeah, as the pivot. So we have two force here about NA and AT. Yes, NA is clockwise, so we can say plus NA and then distance between NA and weight. Sorry, NA and NB as the this is 1, this is 0.5, so 1.5, and this is 4. So distance between A to B is 4 minus 1.5. Yes, 2.5. Correct. Yes, after that we have 80. Yeah, negative. Why negative? Because anti-clockwise. Yeah, when we use the B as the pivot, the rotation of 8 Newton, 80 Newton is anti-clockwise. Correct? Yes, this is we sign negative. So this is 80 negative, yeah, times distance between 80 point to B point. So we have this is about 2.5. So a half of 2.5 is yes 1.25. Yes, enough equals to 0 because we have only two moment on this section. Yeah. So how to solve this question? Yeah. Yes, this is, let's say this is 2.5 Na equals to 80 times 1.25. This is yes 100. Yeah, 100 Newton. And Na, yeah, yes, correct. 100 divided by 2.5, 40 Newton. Okay, finally we get the Na. So how to solve NB? Okay, sorry, I need to you to, yes, I think enough. You can see all my uh, white people. Now we can use the total torque on A equal to 0. Use A as the pivot. So we have two force also, AT and NB. On the AT is positive because clockwise, yeah, times with distance between AT and A, yes, a half of 2.5. Here seem 1.25. And we have NB1 in negative sign because anti-clockwise. Yeah, if we rotate NB, yeah, with pivot A point, so we can say here is anti-clockwise, so negative sign NB. Time between here to here is 2.5 equal to 0. I think you can see here this is same thing with this one, yeah, same thing with this one, yeah. So only just replace it, only flip it, yeah. This is on the right one and this is the left one, this is left one, this is right one. So this the equation is same thing. So we can say NB this is same thing with, yeah, 2.5 and B same with 100. So NB is 100 divided by 2.5. Yes, correct. 40 Newton. Sorry. Yes. In other way, also we can use the total force on the y equals to 0. Yeah. If we already get the normal contact on A as the 40, we can find the NB1, use the formula total force on y direction is 0. Yeah, yeah. On the positive one, on the going up is the positive, yeah. So we can say plus NR minus W plus NB equals to 0. Sorry, sorry, yes. So plus Na minus W minus Nb equal to 0. And now we have 40 Newton, and W we have about 80 Newton, and B we need to find. So NB, yes, same thing with 80 minus 40, yes, 40 Newton. Yes, the same thing one, yeah, the same, yeah, 40 Newton, 40 Newton, 40 Newton. Actually, we can say here, yeah, we don't need to draw everything here, we don't need to draw anything here. We can decide if this is 80 Newton, yeah, and A and B, this is exactly same thing with 80 Newton, yeah, Na plus Nb equals to 80 Newton. So they said this is midway, yeah, midway. This is same thing with 80 divided by 2. 80 divided by 2, yes, 40. So yeah, both of them, yeah, Na on B is on the 40 Newton. Okay, get it? Okay, thank you very much for your watching my video until here, yeah. Please, if you not yet to subscribe this channel, please do this to subscribe my channel, yeah. Okay, now question number 4. Sorry, I think I need to here, yes. A note is the technique torque 16 Newton meter. Calculate the force which must applied to the end spanner of length 24 centimeter in order to produce the torque. Oh, so easy. Torque, yeah, is force time distance. This is 16 newton meter, and this is force. How much force is? And 24, yeah, 24 is in a meter. Yes, 0.24. So F means 16 divided by 0.24. Yes. How much is it? This is this is around 77, yeah. Yes. Newton. Okay, thank you very much for watching my video. Yeah, I think this helpful. Yeah, don't forget to subscribe my YouTube channel. No, click the button of subscribe. Also, you can ring, ding ding, and please like also, and give me the feedback. Yeah, you can say anything about this video or anything you want me to comment, and if is it helpful, please do share it. Thank you very much, and bye bye. You can click other my video. Thank you very much. See.